What's up, everybody? Welcome back to Mathlete's Corner. In this video, we're looking at the 2025 Aime 1 Problem 2. I realized I stopped posting videos about this year's Aime 1 and Aime 2, so here we are. So, in the problem, we have triangle ABC, and on the triangle, we have points A, D, E, and B on side AB, and A, F, G, and C on side AC, and we're given the side lengths. I've already labeled them on the diagram. And then we also have points M and N, and they're the reflection of D and G through F and E respectively. And we're given the quadrilateral DEGF has area 288, and we want to find the area of this funky looking heptagon. The first thing we can notice is that DF and EG and BC are all parallel. And that's because the ratio of the length on the left to the length on the right is always 4 to 13. So we can notice that SAS similarity, right? Now, the next thing to notice is that we're given that DF is equal to FM, right? So let me mark those two here and maybe a different color for FM, right? So we know that those two side lengths are equal. So then we look at the region above that line that I just drew. AFM, the area of that triangle, is the same as the area of ADF, right? Because of same base, same altitude. In this case, the bases are congruent and the altitude is the exact same line. So we can shade in this region and we can get rid of this region, right? We have the area of ADF, and then we still have the rest of this heptagon, and it's still looking really weird. But maybe we can repeat what we just did. So we'll take a new color, say green. If we draw this line, right, by the same idea, the area of this triangle here is equal to the area of, let's actually go to red, the area of this triangle, because those two bases are the same and it's going to the same point E, right? So it's the same altitude. So now we have a new region that we can find the area of instead of FME. Now for FEN, we can notice that that area is equal to FEG. Why? Because EG is equal to EN. So let's shade that in as well. And now finally, we have NECB, and we have this line right here to split that area up into two triangles, right? So NEB, we know that's the same as EGB, and EGB is the same as EGC. So we can shade this region in. And so essentially all we want is the triangle, the area of the triangle. Now we go back into the question and we see what piece of information have we not used yet. And we haven't used the fact that this quadrilateral has an area of 288. So let me go ahead and put that in here. Now let's try finding the area of these other sections, which would be this and this. Let's try finding the area of these sections in terms of the DEFG. So first off, let's say ADF is X, right? Now we know AE is equal to 20, which is 5 times AD. So the area of this full triangle is 25x, right? Because since the linear ratio is 5, the ratio of the areas has to be 25. So that's 25x. Now we know that the quadrilateral is just this big triangle minus the small triangle. So this 288 comes out to be 24x. So we can note that down here. 24x is equal to 288. Now, the whole triangle, so the one with side length AB, well, AB is equal to 28, and that's equal to 7 times AD. So the whole triangle, and just as a reminder, that's what we want to find. The area of the whole triangle is 49 times x. We have 24x and we want to find 49x. Now this is a much simpler problem to solve. Just 49 over 24 times 288. And that comes out to 588. That's all for this video. Thank you for watching. Don't forget to hit that like and subscribe button, and we'll see you next time here at Mathlete's Corner.